Hello, I am Ali Izad Kasti. I am at your service with the second LS servo drive training session. In this tutorial, we're going to learn more about the standard LS series servo drives. Well, the standard LS series servo drives. As we explained to you in the previous tutorial, they start with L3NS. Standard series servo drives definitely require a pulse for control. Now this pulse can be generated by a controller, or it can be created by a PLC, which stands for Programmable Logic Controller. So our controller, which could for example be a PLC, generates a pulse signal. It then sends the pulse to the servo drive. The servo drive is also connected to the servo motor and causes our motor to start rotating. And as we clearly explained in the previous lesson, servo motors are equipped with an encoder which acts as a feedback device. This encoder provides important information about the position and movement of the motor shaft. We can connect the motor's encoder cable directly to the drive, and by doing so, we are able to receive continuous feedback from the motor's movement. This valuable feedback allows us to achieve much more precise and accurate movements in our servo motor, ensuring that the motor operates exactly as intended. Well, today we want to get familiar with a standard series drive itself. And then we'll also get to know the software related to configuring that drive, which is an important aspect of the process. We'll enter the software environment together and carefully carry out the drive's configuration settings step by step, making sure to understand each part of the process as we go along. This image shows us a standard series LS servo drive, which is a commonly used component in automation systems. This part is the display, which has 5 digits. If we remove the cover on this part as shown here, inside there are a series of buttons that we can use for configuration. This is the mode button. This is the up button. This one is down, and finally the last button is for set. So it works like this. When we press the mode button, the various different modes that are available in this servo will appear right here. We can select any mode that we want and then adjust its related settings as needed. With this button, we can increase a value by 1. With this button, we can decrease a value by 1. And finally, when we reach the desired value, we're done. If we press this set button, the particular setting that we have made here will be saved for us. Now, this part is an LED indicator that is specifically related to the charging process. When our servo drive is currently operating, its charge LED indicator is on. These L1, L2, and L3 terminals are all related to our power supply BES asabos BICE. These servos are 3-phase. That means we need to connect our 3-phase power to these L1, L2, and L3 terminals. Now this terminal section, the PO and PI part, is related to the DC reactor. Normally when we want to do the wiring for these servos, we use a connector and place this connector on this terminal. That connector is the one we place here. In the default state, these 2 points of the DC reactor section are short-circuited together. So under normal operating conditions, this DC reactor should typically be short-circuited unless we want to connect an external DC reactor to it. In that case, we connect it to these PO and PI terminals. All right, take a look here for a moment. This is actually a connector that is specifically installed on this terminal. The way to install it is that we can securely and carefully mount it onto the terminal. And as I explained earlier, the part related to the DC reactor, that is the PO and PI terminals, are short-circuited by default. All right, the next part is about the braking resistor. Normally in servos with power ratings up to the range of approximately 7.5 kilowatts, the servo itself typically comes equipped with a braking resistor inside itself. That is, if you look at the back of this drive. In this way, at the back of the drive, there is a default braking resistor installed, which is for up to 7.5 kilowatts of power. These B and BI terminals must be short-circuited. That is, when we carefully place the connector on this terminal, we can simply see that the B and BI terminals are, by default, short-circuited. So, in drives with a capacity of up to 7.5 kilowatts, this part is short-circuited. But for drives with a power that is greater than 7.5 kilowatts, it is necessary to add the brake resistor externally. So in these cases, we add a resistor externally to the B positive and B terminals. This ensures proper operation and safety during braking. Well, this part is specifically related to our control power. The C1 and C2 terminals, which are important components, are involved here. When we connect the three-phase power to L1, L2, and L3, we also need to connect two of the phases to this section for proper operation. In fact, we connect L1 and L2 to these C1 and C2 terminals, ensuring the control circuit receives the necessary power supply. All right, the next part now shows us the main body of the drive itself, which is, in fact, actually the cover of our drive. Now this section is related to U and W, which are actually for our motor. So we need to connect the motor cable to this section, which is labeled as U, V, and W, SAO. An important point to keep in mind is that the U and W marked on the motor must be connected exactly to the U and W on the drive, with each one installed in its correct place. If we connect the U and W terminals in reverse, it can cause damage to our motor because these terminals are designed to be connected in a specific order to ensure the motor operates correctly. Reversing them may result in the motor running in the wrong direction or even cause internal damage. This lower part is called a heat sink, which is used to cool the drive by drawing heat away from it, helping to prevent overheating and maintain safe operation. This part has a USB connector which we can use for configuring the drive. That is, we connect a USB cable to this device and the other end of the cable to our laptop or computer. Then, through the software application related to the standard series drives, we can perform the initial setup and configuration of the drive. These two parts are actually two separate connectors, both of which are related to the RS422 serial port. If we connect a socket right here ourselves, we can also convert this RS422 to RS485, allowing for a change in the type of serial communication. Well, the purpose of these is that, for example, we can use an HMI, which stands for Human Machine Interface, to perform the initial settings related to the drive's parameters. The HMI is a device that provides a way for people to interact with machines easily. Using the HMI, we are able to both read and modify the internal parameters of the drive, which means we can check the current settings and make changes if necessary, all through a user-friendly interface. Well, the most important part of our servo drive is this CN1 section, which is related to our control signal. This has an image. It shows us the image of CN1, which is a very important connector. In the servo, the very first section in what is called CN1 is specifically related to the digital inputs, which actually includes these following parts: the servo on, the emergency stop, the stop, and several other important things that are directly related to the drive, all of which we need to connect to this CN1 section. This section is specifically related to the digital outputs, where the servo itself provides us with a series of digital outputs that we can utilize, for example, for alarms or for other important purposes. For instance, we can make use of them in various ways, and these types of outputs can be very useful and beneficial for us in the context of industry. In many industrial applications, having access to such digital outputs allows for greater flexibility and control over different processes. The next section is related to the pulse input. As I explained to you, I mentioned that standard series servos definitely need an input pulse to operate, and we talked about that input pulse. Now we can generate that using a controller, and that controller, for example, could be a PLC. Well, the electrical pulse signal that, for example, the PLC generates can actually be connected to our servo drive through this section of the system. The next section is specifically related to analog inputs, where we are able to connect a series of different analog inputs to our servo drive. And when, for example, our drive is operating in speed mode, we can control the speed using an analog input. Or for instance, it is operating in torque mode. With this analog input, we can precisely control the torque applied to the system. This section is related to the analog output. We can also get an analog output signal from our drive. And finally, this section provides us with the encoder pulse output, which is essential for feedback. We can use this pulse, for example, by connecting it to a high-speed counter and, in fact, actually get valuable feedback from our drive system. So we can use this as a form of feedback, which means it provides us with information about how the system is working. Now, this part here is called the CN2 connector. The CN2 connector is specifically related to the encoder cable, as it is the point where the encoder cable is connected. This connection allows signals to be sent between the encoder and the rest of the system, helping to ensure that everything operates correctly and efficiently. As we explained in the previous lesson, we mentioned that at the end of our motor, there is an encoder, which actually serves as feedback for us, and a cable comes out of the motor called the encoder cable, which we can connect to this part of the system. After we have securely connected the necessary connectors to the servo motor, for our servo drive, we need to make a series of important settings. For example, we need to specify the unique motor ID for it, or we need to specify the exact type of motor encoder, whether it is absolute or incremental. We also have to set the encoder resolution for the drive, along with any other necessary configuration settings that may be required. So, for these settings, we need to connect our servo drive to our laptop or computer using a USB cable and in the LiveEye software. We perform the initial setup related to the drive. Now let's do these settings together. All right, we open the LiveEye software. Okay, here we select the L3-1S series. We click on the Start button. Now, as you can see, we've successfully entered the software environment. To get started with using the program, the very first thing we need to do is to make sure that we connect properly. So we connect the components together like this first. Then go to the parameter section. When we enter the parameter section, it brings up a table for us that contains several different parts. As you can see here, it is organized into different tabs. Now we will go into the System tab. Here you can see, for example, that it has automatically set a value for the motor ID. So for the motor we're using and have connected to the drive, we need to enter the motor ID here, which we can do in this section. In fact, whatever the motor ID is, we should enter that value here. The next section is called encoder type. If it is set to 0 here, then it operates in incremental mode. And if it is set to either 1 or 3, it works in absolute mode. For a single turn scenario, you should set it to 1. And for a multi-turn scenario, you should set it to 3. And here is the encoder resolution, where we need to enter the resolution value of our encoder. Here is also the operation mode, which specifies in which mode we want to operate. It has torque, speed, and position modes. Now, whichever mode we have in mind, we can enter it here, along with any other settings we need. Here we can make the necessary configurations. If we click on the button labeled All Right, then all of the settings that we have made will be transferred to the drive through the USB cable that we have connected. This action ensures that every adjustment is properly saved to the drive. Now, there are certainly times when we have already made the settings beforehand, and in fact, we want to use those previously configured settings. We can read the settings using this software. If we click on the button labeled All Read, we are able to view all of the settings that were previously configured and saved here. This allows us to see everything that is already present on the drive at this moment. If needed, we can make modifications or adjustments to these settings. After making any changes, we simply click on All Right again, so that the new changes are written and saved to our drive. Thank you for your attention,